All right, so in this lesson, we're going to talk about monitoring of your Azure VMs. Now, you'll recall that when we were setting up the VMs, we did have some diagnostics and monitoring options. Let's go down to diagnostic settings for the virtual machine. Now, Azure monitoring allows you to get deep into the VM and monitor CPU, disk, network usage, and basically we have to turn on guest level monitoring in order for the data to be pulled out of the virtual machine. So think of this as a service running in Windows at the virtual machine level. And so we do need to allow that service to send its data outside of Azure. So that took a few minutes, and we can see that we have access to the diagnostics now that we've enabled it. This is very reminiscent of the monitoring section of this course, so I would say you want to go back and review that. Basically, you can go into any of these tabs and enable what types of data you want your virtual machine to send back to Azure. So we can have those specific performance counters. We can have Windows event logs and various warnings, critical errors, etc., how you configure IIS and failed request logs. Your .NET application can trigger off events and that gets bubbled up, etc. And so remember that we can then go into the log analytics and into Azure Monitor and be able to review what's going on with your account. You also always have the ability to look at metrics. Microsoft has changed the way that they're doing these graphs, so there's a new style. There's also metrics are being deprecated and brand new metrics are being added. We can look at the data read and we can add a new metric in terms of the data write. And we can just build ourselves a graph that's very relevant to us. And then when we want, we can pin this to the dashboard. If we ever want to see data in, data out for this particular virtual machine, that basically becomes a report that we can call back to by pinning it to the dashboard. We can export to Excel, etc. Okay, so that's how we do monitoring within a virtual machine. Now, another type of compute resource is called the virtual machine scale set. So if I look for VMSS, hopefully Microsoft is smart, and it is, virtual machine scale set. Now, virtual machine scale sets allow us to create virtual machines that are scalable from 1 to 100 or even 1,000 virtual machines in a single scale set. So you give the entire scale set a name, so VMSS set 1. We choose the operating system disk image for all machines running within the scale set. I can obviously choose my subscription, which resource group, which location. I do have the availability option. Now, virtual machine scale set are going to be deployed into a type of availability set by default, but if we wanted to, we could deploy that into a specific availability zone. So if I switch over to Central US, I can then choose to deploy my scale sets into only 2 of the 3 zones, or again, because it uses availability sets, it'll do all 3 zones by default. So let's go back to Eastern US. We have to create username and passwords, obviously, for all the machines in the set. And the real fun is when we talk about instances. So now we're creating multiple virtual machines at once. In this case, it can be 2 instances, but it could also be 100 or 500 or 700, however many virtual machines that we are going to need for our purposes. We can choose the instance size, and now Microsoft has only certain instance types that are in this options. Let's see, I scroll down here, all the D's, the H's. There's my B. If I wanted to do this for testing purposes, I can create a virtual machine scale set of B1MS. And basically we can set up scaling rules. Okay, so let's say we know that for this application we're going to have between 2 and 10 virtual machines. Okay, it's already said that the initial instance count is 5. So our minimum is 2, our maximum is 10. And we can set up the scaling rules such that when the CPU reaches 75%, it's going to add 1 additional VM. So in the case where it started off as 5, we add 1, it's going to become 6. And when the CPU goes below a certain threshold, let's make it 15%, it's going to start to take away virtual machines to a minimum of 2. So we might deploy with 5, and if we don't use those VMs, it's going to go to 4, and then it's going to go to 3, and then it's going to go to 2, and that's where it's going to stop. Okay? So virtual machine scale sets have the option to have scaling built in. So the scale set, of course, is going to need to be load balanced. It's going to come with either an application gateway, which handles any kind of traffic, HTTP, HTTPS, WebSocket traffic. It can do things like look at the URL coming in and deploy, basically redirect the traffic to specific VMs based on the contents of the URL. So maybe you have one server that serves the images directory, another server serves the video directory, and a third server serves everything else. You can have sort of rules with an application gateway. A load balancer is a dumb device. It basically just makes some decisions to send your traffic to a random server or in round robin order, etc. It doesn't inspect the traffic. It doesn't expect it to be HTTP traffic. Or you can deploy with no load balancer. Okay. Again, we can choose load balancers can have a public IP address, domain name label. We have to put this onto a virtual network, which we can, because we're in Eastern US, we can put this in a brand new network, etc. And do we want every instance in the 10, let's say there's 10 instances for this VMSS, do we want every instance to have a public IP address? Generally, you're going to want no, because you're going to basically, it's going to cost you money to have public IP addresses. And when you've got hundreds of machines and you're not actually expecting to be able to access the individual machine from the outside because there's a load balancer in front of it, then it's probably smart not to do that. So that's a virtual machine scale set, very similar to VM, but you're basically creating multiple VMs at once, and they all comes with a load balancer, and they all act in concert. They can scale up and scale down based on this type of CPU threshold, etc.